So today the topic that we're going to cover is the cloud native and ONAP management tools for especially for 5G, OSS, BSS. The agenda is on the right-hand side of the slide. So essentially we'll start with some introduction to the cloud native systems, the role of containers, Kubernetes, and so on. And then we'll have a little bit of introduction on the ONAP. ONAP has two components, design and the runtime. So we'll talk about both of them. And then we'll talk about what is OSS BSS, where does it fit in with ONAP, how does it interface with ONAP. And then we'll talk about ONAP's journey for the telcos. So that's where we'll be focusing on. There are other use cases as well, because ONAP is not only for telco, but we'll walk through all the use cases with more focus on the telco use cases. And lastly, we'll talk about what we have done as in Aarna Networks to harden ONAP for commercial use. So we'll have one or two slides on that. So that's the agenda for today. So with that, without any further delay, let's jump into the presentation. So the first few slides are just general introduction. Some of you may be already familiar with it, but let me go through it for the benefit of others. So first of all, what is network function virtualization, NFVs, right? So essentially, there is a transition that's been happening where people are moving away from dedicated hardware that provide fixed function services to a virtualized world. So that's the transition that you see here in the slide. So earlier, every box used to have its own service, firewall, router, switches, and they all used to be connected. So there's a lot of manual management required, multiple interfaces, multiple tools, and there's no practical way of doing dynamic services. That's the most important part. So if you want to change something, you have to rip off some of these and then replace with something else. So it's not very easy to change. So from that, the world is moving to more virtual world where the hardware remains the same. And then you build a virtualized layer on top of it. And they could be virtual machines or containers. So we'll talk a little bit about both during the presentation. So essentially, the whole idea is that the entire setup is going to be agile and it's on demand. Right? So, and the other important part is that everything is automated. So in fact, the entire ONAP project is about automation. So we'll talk about that as well. And in terms of terminology, just to make sure we are all on the same page, we refer to XNFs in the presentation. So what we mean by that is VNFs, CNFs, and PNFs. So the VNFs are virtualized network functions. So these are typically virtual machines. So you build them as a VM and run them on the hardware. CNFs are cloud native or containerized. So they are much smaller in footprint, and there's a lot of move even from VNFs to CNFs these days. And lastly, PNFs are the physical functions, because there are always some functions which are going to be physical. For example, in 5G, the radio is always physical. You cannot virtualize it, right? So the antennas. So those will remain as PNFs. So the important thing is that all of them can be managed in this framework that we're talking about. So another introduction is the reference architecture that you might have seen it in some of these ETSI presentations. So again, just from a terminology point of view, there are three layers that you can think of. So one is the NFVI or NFV infrastructure. So this is the infrastructure, service, servers, storage, switches. So this is the physical infrastructure. And then you have hypervisor running on that to provide the virtualized infrastructure. And then the layer that we are going to focus mostly today is called MANO, MANO, management and orchestration. So this is the layer that you see on the right-hand side on the diagram, which manages the NFVI and XNFs that we just talked about earlier. There is the NFV orchestrator where you can orchestrate, you can place them in different clouds and so on. and then the virtualized infrastructure manager, or the VIM. So the VIM is the layer that you see at the bottommost box on the right hand side. So that is the layer that manages the virtual infrastructure. Right? So there is a clean separation between the layer, the software layer that manages the virtual infrastructure, and the virtual network function managers and the NFV orchestrators. So those are the three layers that you see on the right hand side. And lastly, the actual network functions, which are called XNFs. Right? So these are the ones that actually do the real work. Either 5G or firewall or whatever you are implementing. So those are all running as XNFs. Right? So these are the three layers that you will see reference to them in the subsequent presentations. Now, what is ONAP? Right? So ONAP, we refer to it as MANO++. So what we mean by that is it's more than a MANO. Right? So as per ETSI standards, MANO has certain functions, but ONAP actually does more than that. It goes over and above that. Right? So if you look at the wiki pages on ONAP, what you will see is that it's essentially a comprehensive platform for real-time, policy-driven orchestration and automation of physical and network, virtual network functions. Right? So that's kind of the real definition of that. And again, we'll go into the details and see how it does all of this. But the important thing to remember here is it's a policy-driven orchestration, and it's essentially an automation of the physical and virtual network functions. Right? So in fact, ONAP itself stands for Network Automation Platform. Now, what is the scope of ONAP? Right? What does ONAP actually do? Right? So there are two distinct functions in ONAP. Right? So one is the design framework, the other is a runtime framework. Right? And this is very important because the entire structure and all the projects of ONAP are built on this concept. Right? So the idea is that you can do the design completely independent of the runtime. Right? And the reason is that typically the people who do the design are different from the people who actually run it. Right? So when we say run, to give an example in the 5G world, right, or any telco world, people are the operators who actually instantiate these services. Right? So they are essentially doing the runtime. Right? Whereas design is done by the design engineers who are creating the services. Right? So you take multiple functions, you create a service, right, and then you test it. So that's all part of the design framework. And then once you're done with the design, you push it to the runtime, right? So, and that arrow that you see between design and the runtime, so that is essentially what ONAP calls as models. So the entire ONAP is built on a model-driven architecture, right? So whatever you do in the design, you create a model out of it, and then you push it to the runtime. And in the runtime, the people who are running the runtime, they may not even know how this whole thing is designed, right? What they can do is they can take this model and they can instantiate it. Right? So if, let's say, one customer wants a service, they can go and click on a button and instantiate the service, and that will do whatever it is supposed to do. Right? So that's the important part of the runtime. Right? Now there are multiple components of the runtime which we will come into, but at a very high level, it's the orchestration, which is what is called as NFVO. And monitoring and service assurance is the second part, which both of them will cover in the subsequent slides. So this is a high-level view of ONAP and where it fits in the overall system. Right. The topmost layer is the OSS BSS, and that's the layer which enables customers or partners or whoever to make orders, to create billing services, and so on. Right? So ONAP doesn't do any of that. ONAP provides northbound interfaces, which are typically over REST interface. And using that, these OSS BSS layers can interact with ONAP and perform certain actions. And ONAP is layered on top of the bottommost layer, which is the NFVI, WIM, and SDN controllers. So these are the underlying entities. The NFVI is the hardware and the software that is required to create the virtual infrastructure that we talked about. And WIM is the layer that enables you to control it. Right? For example, some of you may be familiar with OpenStack or Kubernetes, right? So these are the examples of WIM. That's a virtual infrastructure managers, right? So ONAP essentially is layered on top of that. Right? And also the SDN controllers. So there may be some SDN controllers like Open Daylights and Tungsten Fabric. There are several of them in the market. And again, ONAP doesn't do any of that. ONAP can be layered on top of that. So ONAP can interface with SDN controllers to do the SDN functionality. So this is the overall ecosystem and what ONAP does and what other layers do. Right? And then there are some external modules and artifacts. For example, all the XNFs, the packages, applications. Again, some of them we may not have time to go into in detail, but so these are all the artifacts that typically some vendors may do it. Right? So the vendors develop them, and then the telcos, the telco operators, get them, and then they onboard them on ONAP. So ONAP is something that brings all of them together. Right? So that is the overall ecosystem. So in terms of the architectural principles, let me briefly talk about the ONAP, how ONAP is run. So I already mentioned the model driven. Right? So the way ONAP works is that you should be able to do a lot of things without really coding or hard coding, right? So you can install ONAP, and then without writing any code or without upgrading the ONAP software, you can change the behavior. And the way you do it is by adding new models to it, right? So it's a completely model driven. The second aspect is cloud native, right? So the ONAP is completely built from ground up using cloud native architecture, right? So it's all containerized. All the components of ONAP are containerized, and it runs on any Kubernetes infrastructure. Right? And the last part of the ONAP architectural principle is DevOps, right? So DevOps is very important because in case of ONAP, it's not like an afterthought. So it's actually built using DevOps. For example, the different components of ONAP have their own CI/CD pipelines, which can be used to, do the updates and so on, and do the continuous integration and so on. Right. So that is so these are the architectural principles of ONAP. And then some of the details of this cloud native architecture, which applies to both ONAPs and the XNFs that run on top of ONAP. Right? So what are some of the principles? Right? So I will not go into the each bullet here, but essentially I'll just touch upon the high points. So they're all virtualized first of all, right? So all the functions are virtualized. They run as either virtual machines or containers, and they're all decoupled modules, and they run as individual microservices. So you can have each microservice that's working completely independently in a decoupled manner, and you can mix and match them. So, and of course, they're all open platforms. They have open APIs. So people can build applications on top of them using the standard APIs. And then there are some other principles like, you typically scale out instead of scale up. Right? When you need more capacity, essentially you scale out, you create more instances of that. And they're all reusable, they're secure. So these are all some of the principles of a standard cloud native architectures. And ONAP pretty much imbibes all of those principles. But also the XNFs that are onboarded on ONAP also follow the same principles. Now, coming to the how ONAP maps to the ETSI MANO framework. Right? So I talked about why ONAP is called as a MANO++. right? So what that means is it does over and above what MANO standard specifies in ETSI, right? For example, MANO doesn't, the ETSI standard doesn't talk about design environment, right? But ONAP supports a design environment. So that's an additional functionality of ONAP. Similarly, the monitoring and service assurance are not part of the ETSI MANO framework, right? But ONAP supports that. And again, we'll talk about it, the monitoring and service assurance, what it does. And lastly, the SDN controllers. So that's typically outside the scope of MANO definition in ETSI. But ONAP supports it. ONAP has the SDN controller, which can talk to the external SDN controllers. Right? So these are the functions of ONAP that go above the MANO functionality. So this is an overview of ONAP and all the different components. And again, we may not have time to get into each and every item here, but I will just touch upon the high points. There is a design time and the runtime that I mentioned earlier, right? So both the design and the runtime have a GUI interface in ONAP. It's a portal through which you can do the design and also you can do the runtime. In the design time, essentially you onboard the resources, you create a services, and then you create all these closed loop designs. So again, once you start getting into more detail, you will know how flexible it is in terms of being able to do a lot of these functions. So that's all in the design time. And the important part is that there's something called a catalog. So where you can create all these models and store them in the catalog. The advantage of that is that it becomes reusable. So let's say you create a model and you push it to the catalog, and another developer or another user wants to use something similar, they can just use that. As long as you publish it as an open item, they can reuse it. So that is the advantage of this model-driven architecture. And finally, when you're done with all of this, you distribute the model, and then it goes to the runtime, which picks up all of these models, and then it has something called service orchestrator, which is the main component of the runtime. And that allows you to create instances of this model, right? So there are a few other components, and I'll briefly talk about them. So there's something called active and available inventory in ONAP. So that's a single source of truth in ONAP. So essentially everything that you do in the system, all the models you create, all the instances that you create, how they are related to each other. So they're all maintained by the active and available inventory. So essentially, that's one place where you can go to get all the information about your deployment. So that's the single source of truth. And then, of course, there are controllers for doing the SDN infrastructure that I just talked about. And lastly, there is a module called data collection analytics and events. So what it does is, it's called DCAE, stands for data collection analytics and events, that allows you to collect events from your infrastructure or from your XNFs, and then you can run some analytics on those events and take some actions. So if you remember, I talked about the service assurance, right? So that's essentially what service assurance means. So you can take events from these XNFs and then do some analytics on that and take some corrective actions. For example, if there are so many errors, you do this. Or if your load is so much, you do this, right? So so you can create those types of policies so that the automatic actions can be taken without really writing any new code, right? Because the whole idea is that we don't want people to start writing code to develop, change the behavior or add this functionality. So all this can be done by some kind of a descriptive policies that even a non-programmers can do it. So that's the whole advantage. So that's a very quick overview of ONAP, what the functions are. Now let's talk about the external interfaces and what are the different ways that you can interface with ONAP. And some of these interfaces are aligned with MEF and TM forum specifications. So it's not 100% alignment because some of them are still work in progress. For example, there are some TMF standards where it is aligned, some it's not, but it's a work in progress. So the OSS essentially enables you to do the capacity management, supply chain management, handling failures, providing the KPIs, right? So it provides an interface for it. For example, vendors may have their own OSS portals, right, where they can allow you to see the KPIs, look at the errors, change the add additional capacities. So all of that is done through these OSS layers, right? And these OSS layers can interface with ONAP using the well-defined APIs. Right? So that is the interfacing that needs to be developed, right? So the other is the billing side, right? The BSS. And again, similar to that, the billing information, the user events, SLAs, all of them can be either configured or reported on the BSS platforms. And again, the BSS platforms can interface with ONAP using these well-defined interfaces, right? So that's the role of these OSS BSS layers and how they interface with ONAP. And then you can perform all the functions that are required for the end user or the operators. Now, so we've seen a very high level overview of ONAP, right? So now what are the ways that you can customize ONAP, right? So there are multiple ways, right? So at the lowest layer is creating models, right? So I already talked about how you can create models in ONAP, right? So it enables you to add VNFs or CNFs, create services, add policies, recipes. So these are all the models that you create in some kind of a modeling language, right? And then you can onboard them on ONAP, right? So that doesn't require you to add any code in ONAP, modify ONAP, reinstall ONAP. You don't have to do any of that. So you can have a running system, and then you onboard all of these models, right? And this doesn't require a lot of any programming knowledge or in-depth understanding of ONAP. So you can just do it by understanding how the ONAP, VNFs are structured and so on. Right? So the next level is using ONAP SDK. Right? You can develop analytics applications, data collectors, dashboards. So these are some of the functions that are already present in ONAP, right? But let's say as a user or as a developer, you want to enhance them. You want to add some new analytics functions, or you want to have some proprietary way of collecting data, right? Or you want to create some dashboards that are specific to your organization, right? So you can develop all of them using the ONAP SDK, right? So this will require some programming knowledge, right? So, and then the last model or the last layer is ONAP code itself, right? Because ONAP is completely open source, right? So any organization or any individual can contribute to ONAP. They can fix bugs, they can review commits, they can add new functions, but you have to be part of the community to do that. And there is a process for doing that, right? So these three layers are roughly in the order of complexity, right? The lowest layer, the models, are the easiest way to contribute to ONAP because you don't really require deep understanding of ONAP. You don't require programming knowledge. So you can develop all of these models using the modeling languages, right? The second level requires some programming expertise. And the third level requires some deep expertise of ONAP. Right? So each one has its sort of increasing complexity. Okay. But the message of this slide is that you can contribute at different levels without really being a programmer. So, and lastly, the ONAP will take some effort, right? So ONAP is not something that just works out of the box, right? So you go install ONAP and then, nothing happens, right? Because it doesn't, by default, it doesn't do anything, right? So it's like a platform. It's like, installing a operating system on your computer, right? So unless you install some applications, it doesn't really do anything, right? So the same thing with ONAP. So it's like a platform. So when you install it, you have to do certain things to make it do something useful, right? So, and this is what this slide tries to identify. What are the things that you can do? So one is VNFs. So you have to either develop VNFs or you have to, get them from some vendors and onboard them. And then you have to create services out of them. And then you have to, either use some of the workflows that are already present, or you have to create some new workflows, policies, collectors, analytics applications, OSS BSS interfaces. So again, all of these are functions that you will have to do on top of ONAP, right? And again, some of them are already existing in ONAP, so you don't have to, develop everything from scratch, right? But if you want to change them, for example, you want to create a new service, which is currently not there in ONAP, right? So you have to create that. Similarly, if you want to change some workflow, which is already there in ONAP, so you'll have to either write a new workflow, or you have to modify an existing workflow, right? So these are the things that need to be done to make ONAP do something useful. So it takes effort. It's not something that where you can just install ONAP and expect something to happen. So this slide just gives a very high-level overview of some of the alignments. So those of you familiar with the MEF and the TM forum, there are some standards. For example, MEF has Allegro, Legato, Interlude. So again, ONAP has some alignment with some of them. Similarly, with TM forum, there are some standards which ONAP implements. Some of them are work in progress. Some of them are fully implemented. So this talks about the history of ONAP. So ONAP has been there for close to 4 or 5 years. So it started in 2017. The first release was Amsterdam. So in fact, ONAP releases go by alphabetical, right? So it's A, B, C, D. So Amsterdam, Dublin. So it's a city name starting with an alphabet, right? So the current release is actually even beyond this. In fact, the current release is I release, which is Istanbul. So this slide talks about Quilin, which is the last in December 2020. And after that, there were 2 more releases, H release and I release. So this talks about the Honolulu release, which is the prior release. So just to give a flavor of who are the contributors, how many commits happen. So it's a very, very, very active project. A lot of contributors, a lot of the companies, most of the telcos in the world, across the world, are part of ONAP project. So they have teams that are contributing at different levels, of course, and in different components. So just to give a flavor, 30 organizations, 24 projects, 151 Git repositories, 207 authors, and roughly 3,000 commits. So it's a very, very vibrant community, very active community. And in terms of the percentages, these are some of the companies that are active contributors. So now let's just talk about some of the use cases. And, even though it talks about Frankfurt release, it's applicable to all the releases. So some of them are applicable directly for telcos. Some are generic, can be used by enterprises for other applications. For example, there's a virtual firewall and virtual DNS, which is a standard. It's an open source version, which is present in ONAP. So this is probably the easiest one that somebody can try out if they want to start using ONAP. And then there are a couple of these residential use cases, VCP and BBS. There is another one, OLT. Again, it's voice over LTE. It's not, so some of them are, by the way, not open source. So you will not see them in the, when you actually check out from the ONAP public repositories. So you may have to talk to the commercial vendors for some of them. Some are open source that you can use. Similarly, there's a CCVPN use case for slicing and MDONs. There's a 5G, which is very popular now because of the interest in the 5G. So this gives a flavor of each use case. Again, we don't have time for every specific use case, but essentially the firewall is a very simple virtual firewall demo. It's more like a demo. It's not a production use case. So it shows you the entire life cycle of a VNF, how you can onboard a VNF, how you can create a service and a policy, and then you distribute it. And then you go to the runtime and then you do a deployment. And then you can see it in action. You can see that there's a traffic generator, there's a firewall, and then there's a sink. And you can see that the traffic is flowing through the firewall. So you can see that simple application. And you can also create a closed loop with the virtual firewall. So that's another example that's there in the open source ONAP. So it's a very interesting closed loop application where it receives the events and then takes some action. And based on that, on the action, it actually reduces the packet rate from the packet generator. Right? So you can actually see the closed loop in action, where without any manual intervention, you can see that the packets are generated at certain rate. And then over a period of time, when they cross certain threshold, automatically there's an action that is taken so that the packet rate stabilizes. So that's a closed loop automation that you can see. And essentially with this application, you can see the entire ONAP operation. And this is the simplest one for somebody to get their hands dirty and try it out. So VCP is again a little more complicated. There are multiple VNFs in this. Again, it's not a production CPE. It's an open source CPE, which you can instantiate on your own app framework and manage it. And all of them are open source components, so you can actually try it out. It's based on the Fido project, fd.io, and the VPP projects. Similarly, there's a broadband service. So again, some of these are not open source, so these are proprietary that you will have to work with a specific vendor to instantiate them and to use them. So again, all of this virtualized BBS service can be created using this blueprint. So once you have the license for these proprietary components, ONAP will allow you to create a service, instantiate them. Similarly, VoLTE. So it's a proprietary service, but once you have the license for all of these components, you can use ONAP to orchestrate and instantiate them and start using them. And by the way, all the vendors that you see here, ZTE, Huawei, Nokia, all of them have done the integration with ONAP already, right? So these blueprints are pretty much ready to use. So you can just take all the models that are created and start using them, assuming you have the license to use the proprietary components. Yeah, so there's some of the other use cases. For example, the CCVPN is another use case where if there are two telcos, how they can be interconnected over over two different domains. So the idea of this is that ONAP can be used for sort of inter-domain communication. So in this particular example, there are two different vendors, two different telcos who have used ONAP. So each of them have their own ONAP installation, and they communicate over the MEF interlude interface, and each one can orchestrate their own network functions. So MDONS is again another multi-domain optical network service. It's again a proprietary service where ONAP can be used to orchestrate them, start up all of these different network services and so on. Lastly, 5G. There are multiple vendors who have developed 5G, which are either virtualized or containerized, though we see a lot of them using the containerized framework for 5G. Again, ONAP allows you to orchestrate them. For example, 5G has multiple services, right? AMF, SMF, PCF, and you can orchestrate them on either one or multiple clouds. You can create networks between them. You can do all of the lifecycle management. You can upgrade them. So all of the starting from orchestrating them to managing them to deleting them, you can do the entire lifecycle management with ONAP. So there are a few other things which are more detailed. Some of these network services provide configuration interfaces over multiple interfaces. Some of them provide netconf, some of them are over REST interfaces, and ONAP supports all of them. So there are components in ONAP using which you can configure something over netconf or a REST interface. Similarly, another important aspect is the ORAN, right? So again, that's a completely different topic that we can go into later, but essentially ORAN is a software community, which ORAN SC is a software community which is implementing the reference architecture for Open RAN, right? So, and ONAP can interface with the components. In fact, ONAP implements some of the components required for ORAN. There is a component called SDNR in ONAP, which implements the SMO functionality of ORAN. So probably the last one is the network slicing. So this is again another use case that's getting a lot of attention, and ONAP supports network slicing, which essentially enables you to take the multiple domains in, for example, in a 5G network, and create multiple slices out of that. Right. So this is one of the very important use cases for 5G, right, where you can take a single pipe and have multiple slices with different SLAs potentially. Right? So, for example, you can create one slice that is used for virtual reality applications, maybe another slice for industrial sensors, right? One for drones, one for maybe some emergency services, and each slice may be optimized for different use case. For example, one slice could be optimized for high bandwidth. Another could be for very low latency, right? So you can have different characteristics for each slice. So now, what is the role of ONAP in this, right? So ONAP will allow you to create these slices, activate them, and modify them, right? You can do the lifecycle management of these slices. For example, when you create slices, you may have to change the characteristics of the slice. Right? So ONAP allows you to do all of that, and it has workflows to do all of these functions. So next, I just want to briefly touch upon the collaboration between ONAP and ORAN SC community. The ORAN-SC essentially is an independent community, software community, but there is a lot of collaboration between ONAP and the ORAN-SC community, right? So, for example, ONAP implements some of the functions that are required for ORAN specification. For example, SMO, right? So these are implemented by the ONAP, and then also some of the SDNC layers in ONAP are enhanced to a project called SDNR, and that is the module that implements the SMO functionality. So that's where this collaboration comes in. Now, lastly, what have we been doing as a company? What is Aarna's role in all of this? So essentially what we do is we provide a commercial support for a subset of ONAP that we call as AMCOP. So essentially AMCOP is very functionally similar to ONAP. It does everything that ONAP does, but it uses only some components of ONAP because we focus only on certain use cases, right? So that's what we do. And the specific use cases that we are focusing on are 5G and Edge. So again, the technology ONAP is very generic. You can use it for multiple use cases, right? But the functionality that we support in Aarna is specific to 5G and Edge use cases. And for that, we picked some of the components from ONAP. Again, I will not go into the detail because unless you are familiar with ONAP projects, you may not be familiar with it. But essentially, these are the projects that you see in ONAP that we are actively participating. So we contribute and we also use them. We support them as a commercial distribution. So if somebody wants to productize it, essentially they can come to us, and we provide a commercial distribution for this. So think of it as a Linux analogy, right? So Linux is open source, but there are companies that build commercial distributions for Linux, right? Like Red Hat and so on. So we are something like that. So we take the open source ONAP and then we provide a commercial distribution for a subset of that. So that's what we do. And as part of that, we have done a lot of hardening of some of the components to make them usable for a production deployments. So lastly, how do you get involved in ONAP, right? So again, I mentioned in one of the previous slides, so there are essentially two ways you can get involved. So one, as a developer, right? As a developer, you can start with ONAP wiki page. So I have references to that. You can join the community. It's free, it's open, anybody can join. You can read about all the projects. You can join the mailing list. You can even join the calls, the weekly calls that happen. You can download the tools. You can read about integrating with ONAP. You can attend the events, which are again, open events, right? So these are all the things that you can do as a developer. Now, as a user, again, you can join the community. You can start deploying ONAP. You can try out different use cases that I mentioned, virtual firewall, virtual CPE, and so on. And of course, as you gain expertise, you can get more and more sophisticated with all these use cases. So these are the ways that you can get involved with ONAP. So this has some of the references to ONAP documentation. Again, the project is open, so it's available. There's a wiki page. There is a read the docs reference site, which is mentioned on the slide. So you can look at all the documentation. You can download it. You can install it and try it out. So that's so there is a ton of information that's available to learn about it.